possible outcomes. We can have 0 girls, 1 girl, 2 girls, 3 girls, 4 girls, or we can have what? 5 girls. Are you guys okay with that? P of x. What's the probability you have no girls? We deduce this, 0.03125. What's the probability you have 1 girl? Point what? 15625. What's the probability you have 2 girls? What was that? What does it say? 0.3125? And what's the probability, bless you, that you have 3? Is it also 0.3125? Okay. Why am I writing this down? Why am I doing this? You guys know? Because question 9 is asking me, excuse me, thank you, to determine the expected value, or the expected number of girls here. Okay? So if I'm going to do that, what do I have to do? I have to determine the x times p of x column. And then what do I do with all those probability values? What do I do? You add them all up. You guys okay with this? So did anybody compute P of 4 and P of 5? Anybody compute them? You guys want me to do it for you? Oh. 0.15625 is P of 4. 0.03125 is P of 5. Do you guys know that? Okay, let me just say this to you guys here, okay? It's a fact. You guys see a pattern here? What's the pattern? The first and the last have the same value. The second and second to last is the same value. The third and third to the last is the same value. This is a special feature of the binomial, okay? So this happens for any binomial problem that has p equals q equals 1/2, any child problem, okay, for the children. Now, you can go the long way and do this, all right? You can compute those values, get the x times p of x column, 0 times this value, isn't that what? Isn't this 0? 1 times 0.15625 is 0.15625. What is 2 times 0.3125? Is that point what? Is that 0.625? And what is 3 times 0.3125? What's that going to be? 0.9 what? 375. What is 4 times 0.15625? Is that 0.625 as well? And what is 5 times 0.03125? Point what? 15625. What do you do with these values? Anybody know? What do you do with all these values? You add them, and what did you get? 2.5. So here's what's going on. If you have 5 children, okay? 5 children. Every couple in the world that's ever had 5 children, do you guys know that some couples had no girls of the 5? That means they had all boys, right? Some couples have had what? 1 girl. Some couples have had 2 girls. Some have had 3, some have had 4, some have had 5. Do you guys know this distribution right here will say that, you know what? About 31.25% of the couples had two girls. About 31.25% have the 3 girls. But the long run average, if you have 5 children, you can expect to have 2.5 girls. This is the expected value. Okay? And you may sit there and go, wait a minute, wait a minute. I'm having 5 children. How is it that I can expect to have 2.5 girls? Because this is a what? Average. This is an average. This is a long-run average. So you may go, well, there's no way to have half of a girl. That's true, but it's an average. Because again, some have had none, some have had 1, some have had 2, 3, 4, some have had 5. What's the average? 2.5. That's the expectation. So this is why you also call it the long-run average, 2.5. That's like, you remember the statement that the average number of children American couples have is what? 2.2 children. There's no way you can have 0.2 children, but it's an average value. Okay? How many pets does the average American couple have? What do they have? How many? I don't know. 1.2? I don't know. Okay? So this is the expected value. It gets even better. You guys ready? Let me ask you this question. If you have 12 children, what is the expected number of girls? What do you think? What is it? 6. How do you guys know that? You didn't go through this distribution. You didn't compute 12 probabilities. Multiply those outcome sums of probability. Did you do that? And then add the values? You didn't do it. So what's the story? How did you get the answer? Here's a fact. This is only true for the what? Binomial. Mu equals n times that little what? P. Okay? The expected value is n times p. So in this setting, what's the value of n? How many children? 12, right? What's the value of p? Isn't that 1/2? That little p is 1/2? Why? The probability of a success for a single trial is 1/2. So what's 12 times 1/2? In this example, mu is what? 6. So if you plan on having 12 children, the average number of girls that you'll have, all couples that have 12 children, is going to be 6.